should be good. Okay, so first multiple choice question was circle the letter for the best response. If x is an int variable, when does the Boolean expression below evaluate the true? The correct answer was D. Does anybody want to go over this? Okay, cool. Second one was 1.2. Consider the following statement. If I modulo 2 equals 0, return false, else return true. Who can tell me in like plain English what this is doing? What this will return? What does it usually mean when we're doing modulo 2 louder? Yeah, exactly, except it's the opposite. So it'll return false if it's even, true if it's odd. And the correct answer for that was C. Does anybody want me to go through that?
Why is it C?
Yeah, so with these ones, I would say it's best to sort of look at like a few examples, right? So you have I, which is I, which is like an integer. Let's say we're going to test two different values. Let's say 3 and 2. So for that first one, I modulo 2 is 1. 1 is not equal to 0, so this will return true. And then the second one, if I modulo 2 equals 0, which it does, 2 modulo 2 is 0, so we would return false. So we're looking for whichever statement gives us the same outputs as this. So true for 3, false for 2. So we can look at A, which is just return I modulo 2 equals 0. So for the first one, let's see. 3 modulo 2 is equal to 1. 1 is not equal to 0, so this is false. So automatically we can rule out A because it's not giving us the same responses as the one above. So that one's no bueno. Then return I modulo 2. In this case, we're returning, let's see here, 3 modulo 2 equals 1, which is true. So in this case, it would work well. However, let's say that instead of that, oh wait, what am I doing here? I modulo 2 does not equal to turn I modulo 2. Which statement is the equivalent? So I think in this case, because that's actually a good question, because it would return either 1. Oh, 1 is true, 0 is false. Huh. I actually have to ask Bucci about that, because technically you can use integers as Booleans. So in this case, this would return 0, which is equal to false. And this one will return 1, which is equal to true. So if you answered this, actually, I'm going to email Bucci about that, because technically that's right. Because Java, I think Java treats integers as Booleans. So,
So one A or C.
It could potentially be B or C, but I'm sure Bucci's gonna yell at me.
Could I answer it?
Yeah, I'm gonna email Bucci about that because technically that's true. Which of the following statements is it equivalent to? He's probably gonna say that because you're returning an integer instead of a Boolean value, it's not correct, but I would push back on that, honestly. The correct answer was C, though, the one that they wanted. So I modulo 2, let's see, 3 modulo 2 is 1. 1 is not equal to 0. That is true. And then the opposite is false because 2 modulo 2 is equal to 0, which is false. But I'm going to email Bucci about that because, yeah, but Java treats integers as Boolean values. Yeah, so if you have, I want to say, this might be me just being bad at Java. Like 1, I think so. At least, I'd have to double check.
1 or 0 is still like
true and false.
I know, but it's not like
yeah, but I know in Python, at least you can treat 1 and 0 as like true and false. Like
Like
it will
means that
interpret it.
Boolean Equal to 1 and 0, but.
Yeah.
because- Right, I don't-
And that's why I think Bucci's gonna say that it's not correct. In any case, the more correct answer, I suppose, would be that C value because you're returning true and false for the truth table. But I'll email Bucci about that. And then D, 3 divided by 2 equals 0, equals true. So in this case, 1 equals 0 is false. False equals true is false. So this would return false, and then the opposite would be true. So for these types of questions, it's best to just use a bunch of examples. But I'm going to email Bucci about that because I feel as though it's semi-correct. So we'll see. Okay. Then this one actually, like a bunch of you guys got wrong. So we're going to go over it. So we have this private static void modify, which takes in 2 formal parameters, int first, int second. It increases the value of first and sets this value of second equal to second plus first. So we have 2 integer variables, x and y. X is stored as 2, y is stored as 7. And then we modify x and y, so we pass x and y into the static void function, and then we print out the values of x and y. And the correct answer here is that the values do not change because integers are passed by value instead of passed by reference. So now that we know more about reference types and we know more about immutable and mutable types, this should hopefully be a little bit easier to understand. But are there any questions about that? Essentially, values are passed by value instead of passed by reference. Okay, next up, yeah, question.
Is there a time where it's not passed? So if it's like int first equals 2 and then second equals 7.
Wait, sorry, what was the example?
What is the time where it's not like a pass by? What would you simplify?
So
It's
if x and y were natural numbers are passed by value or passed by reference instead of passed by value.
So like when would it be would stick to that static void? So like if where it would be like 310.
Never.
Like if you change the code.
You would have to change it to use not a primitive type like integer. In no such case will modify. Get out. If say modify returned like an integer and then you set x equal to the result of modify, then maybe it would return it like. Are you okay? What's going on? Okay, well, if it happens again, then you're kicked out of the class. Okay, so when you have passed by value in like primitive types, x is 2, y is 7. When you call the function modify, the values of x and y are copied into first and second. So first and second have these values of 7 and 2 at the beginning of the static method. And then when you increase first plus, it makes this 3. And then when you second equals second plus first, reset it to 10. You're modifying first and second. You're not modifying x and y, which is why when you get back, Java deletes these temporary variables because they're no longer in scope. And x and y are just the same value.
Oh, because they don't print out first, second.
Yeah, you couldn't print out first, second because first and second only exist within the confines of this static method here. Okay. Now, 1.4 in design by contract, the person that calls the method is responsible for making sure that the precondition is true when the method is invoked. I think I said this like 80 times, and I think most of you guys got this right. So there are no questions on that. Just feel free to like yell if you have a question about something. Okay. What is the value and type of the Java expression 2 times 5 divided by 4? So we can go through the example here. 2 times 5 is 10, divided by 4 is 2.5. However, Java does not store doubles and integers. So what it'll do is it'll just chop off whatever's to the right of a decimal point and leave you with just the integer value. So the correct answer there is D2. Okay, so a compile time error. C prevents the program from running. So this could be, say you have an integer or you try to out.println or out.print a variable x and you haven't defined x. Java's going to get to that and it's going to say, I don't know what x is, and then it'll crash and prevent the program from running. So correct answer there was C. Okay, this is another one that a lot of people got wrong. So consider the following method header: private static void cube int num, and the client code int number equals 2, and then we call cube on number. The value of number after the method call is guaranteed to be 2, and this is for the same reason as the other question that we just talked about, which is that integers are passed by value instead of passed by reference. So you can't modify number because the value is being copied into num. We all good on that? Yeah.
That's why the reference string.
Not the only time. That gets into like mutable and immutable types. So we talked last week that arrays are passed by reference, strings, natural numbers, and then those are split into mutable and immutable types. So immutable types can't be changed within a method body, and mutable types can.
Okay.
All right. So now we get into the short answer. This one goes back to a few questions ago. We have an integer 8. We're saying while x divided by 3 is not equal to 2, we subtract x from 1. And how many times will the loop execute? Well, we go to the first one. 8 divided by 3 will be equal to like 2.67. But again, since Java cuts off all of the things after the decimal point, cut this off, and what will be left is just an integer 2, and 2 is equal to 2, so that does not enter the loop, so 0 times is the correct answer here. Okay. Fill in the table below with the value of the type and value of the expression. Assume the variables have been initialized as follows. Okay, so this first one, we have n plus m modulo 2 equals 0. 1 plus 2 modulo 2 is 1. So that's going to be a Boolean with the value of false. Second one, d times n divided by m. So we have, let's see here, 5.0 times n, which is 1. So that's 5.0 divided by m, which is an integer. One thing to note here is that because we multiply using a double, so d is a double, 5.0, n is an integer, Java just makes sure that everything is a double if you multiply a double and an integer. So that's why when we divide by m, the answer is a double with the value of 2.5. Now, this one tripped up a few people. We have the string 10 plus the integer 24. And what Java does in this case is it converts the integer into a string and then concatenates it onto the other string. So in this case, you would have the string 1024. Shoot. You have string. And okay. The next one, we have a Boolean here. So we have b, which is equal to true. So we have true, and I'm just going to use 2 pluses because I don't really want you guys to make fun of me for drawing an ampersand. And then we have a double condition here. So in the first one is m is less than b, 2 less than 1, which is false. We have false or not b. So not b is equal to false. So we have false or false, which just evaluates to false. So true and false evaluates to false. So this is a Boolean that is equal to false. Okay. And then the final one was n divided by d. So 1 divided by 5.0 is 0.2, I believe. Yeah, 0.2. And then we're adding on to that m, which is 2 divided by 5.0, which is 0.4. So the answer is 0.6. So that would be a double with the value of 0.6. Are there any questions on any of those? Going once. Yeah.
For the string one equaling 1024, is there ever like an example where the string would get converted into an integer?
No, because Java doesn't know what's in that string. It just knows that it's a string. So I'm like 99% sure that's true. Because there's a string method called like can parse int or parse int. And in that case, if what's contained within the string is an int, then you could parse it into an integer. But since Java doesn't know, if you just have that like 10 plus 24, like that string 10 could be like the entire script of Joker 2, and Java doesn't know that. So if you try to add an integer on it, Java will get very angry at you. Because A, it's a bad movie, and B, it's not an integer. Okay, any other questions?
Wow, I love how we just talk about it so bad we can't even call it by its full title.
Joker, I don't even know Folie de. I didn't
Folie
take
de
French.
deux, so
What do you gotta do?
It's just madness of two.
Oh, really?
It's French.
I didn't take French. I took German.
I took French. I love French.
Any Gates? Any German speakers in the audience?
Yeah.
Es geht mir gut. Du bist ein Lebensmittel. You are a grocery.
I forget
I remember that, and I remember Ich habe drei Messer, which is I have 3 knives. Yeah.
I just remember that the
All I know
virus is the Kronken.
Krankenschwester, yeah. Yeah.
all I know is that one of my friends, my meat master friend, is taking German right now.
It's a funny language, man. I think pen and pencil have the same word. They're just both just Keller, maybe. I don't know. It's a weird language.
No, the word for ball.
Is what?
Google Schreiber.
You don't remember a lot of things. You remember the word for ballpoint pen. That's
Word for locker.
that's-
I never know when I'm gonna be in Germany. You need a ballpoint pen.
I think basement is Ein Keller, because every single time I had to have a presentation, I would include somebody who was just in the basement for some reason. I don't know. My German class was weird, man. He was a chiller though. Okay, guys, focus. For each of the following statements about XML trees, indicate whether that is true or false by circling the appropriate value. So every node in an XML tree has a label. This is true. Because either you have the label, which is under the label, or if there is no children, then whatever the tag is gets called as the actual label. Then every node in an XML tree is either a tag or a text node. That is true because it's either a tag or a text node. Tag nodes cannot be leaf nodes. This is false. A tag node can just be a tag node. And then a text node can have 0 or more attributes. This is false. The only things that can have attributes are tag nodes. Any questions on any of those? Cool. Okay. Statements and expressions. Do we want to go over this? Everyone did pretty well on this. Essentially, the only thing people messed up is that if you have something like an if statement, I don't want to write out the entire if statement. You just draw a box. I'm not going to draw. That would get me in trouble. You draw a box around the entire thing. So a statement includes everything that's contained within the curly braces. And expressions are things that evaluate something. Are there any specific questions on any of these like lines or expressions in general? Okay. Yes, questions.
So when you're drawing a box, I think I got like 1 point. I think that have to be separated whenever you do, whenever you like circle each of them.
What do you mean separated?
Like you don't like circle the entire thing. I don't remember why, I don't remember, but it's, so it's something, I remember I got one.
It might have been because you forgot to circle like the entire, like, you can't just circle like while, you have to circle like, the entire box containing the while.
Oh, I think that.
Yeah. For simple expressions, you just box around this, but for if statements, while loops, those sorts of things, you draw it around the entire thing. Okay. Next one, we consider the following method contract here. In one short sentence, explain what the result of the following call will be and why. Or if you cannot predict the result, explain why. You cannot predict the result in this case because the precondition is not met. So we have that it requires x plus 1 is less than 2 times y minus 3. So in this case, x is 5. So 5 plus 1 is 6. 2 times y, 2 times 4 is 8. 8 minus 3 is 5. 6 less than 5. This is false. And whenever the precondition is false, the method is allowed to do whatever. This method could scrape your IP address and order you like $1,000 worth of pizza to your house. It could do anything. We can't predict it because the precondition is not met. Any questions on that? Okay, awesome. Do we want to go through the tracing table? Because it's a lot and I would have to like copy down everything. What I will do actually is I will take a snippet of the correct answer, and then if you guys have any questions, we can go over it. But tracing table went okay. Okay, so this is the correct answer. People got points off because they did not indicate that they skipped an iteration by using either an underscore or a slash. People got points off because they were keeping track of variables outside of the while loop. So this line right here, int max equals n, is only going to execute once at the beginning of the method. So you don't need to keep track of the variables every time you go back up to the while loop, and vice versa with the end of the while loop as well. So it's only going to break out of the while loop once, so you only need one value here. A lot of people like moved over their digits to the right here. But since it's the first iteration of this, I guess, execution of code, it should always be pushed to the left. I didn't take points off of that. But I don't know if somebody else who's like I'm not gonna say it, an annoying grader would. So just make sure that it's always pushed over to the left. Any questions on this? Going once, or going eins, going drei. Wait. Right, yeah. Wait. This is why. Damn. Okay. Okay, that's the tracing table. All right. Now complete the body of main so that it prompts the user to enter in a positive integer, say n, and then prints the triangle of star with n rows, where the first row has 1 star, the second row has 2 stars, and so on and so forth into the last n. Here's a sample interaction. So an example of how you might do this, or I'll just go over like what people got wrong. So one thing, make sure you're reading the instructions. It says make sure your program output and output, program prompt output and output match exactly the example above. So you needed to have an out.print, enter a positive integer, and then read in the following integer. So int whatever equals in.next integer. And then most of you had a example that was either 2 for loops. So starting at int I and going till the number of rows that it had in I, and then you had an inner for loop, which was int j going through and then printing out the number of stars and then a new line at the end. Or you had a string and then you kept concatenating on stars, which was clever, and then just printing it out. Do we want to go through an example of what a sample solution of this would look like, or no?
Yes.
Okay, cool. We will do that. Okay, so first things first, you want to have your prompt. So out.print. I'm gonna wrap the space, but it was like that. Okay. Out.print. Actually, we're gonna do it in Eclipse because I don't feel like writing code.
It's much easier to type, but anyway.
It is much easier to type. You are correct. So let me pull up the program skeleton.
Actually, wait, Steven,
Yes.
how much better is C compared to MATLAB?
How much better is C compared to MATLAB?
Yeah.
Nothing's better than MATLAB. MATLAB is peak programming language. And every other programming language is just a fake that is trying to be MATLAB. Okay. Yeah, exactly. MATLAB wannabes. Okay, so let me see that. Okay, epic. So we start by out.println or out just .print. Wait, let me pull up the prompt here. We would say
MATLAB lobbies. Why are you not teaching in this class?
because I'm not nearly smart enough to teach you all of the intricacies of MATLAB as it pertains to being a good MATLAB programmer. It's far and above my pay grade. No, I think C is better than MATLAB. Okay, so you start entering a positive integer. We can say int num rows equals in dot next integer. Great, like that. So first thing we need to do is we're going to need a loop through however many rows it is. So let's say it's like 5 rows. So we can start by saying for loop for int I equals 0. I is less than num rows. I plus plus. And just as a tester, we can just out.println. Let's just print out a star to make sure that we're printing out the correct number of rows. So enter a positive integer 5. And you see we have 1, 2, 3, 4, 5 rows. So that part is correct. Now we just need to print out the number of stars based on how many rows it is. So we can say for int j equals, in this case, we're going to say 0. J is less than, say, I plus 1. Because when I is 0, we want to print out 1 star. When I is 1, we want to print out 2 stars, and so on and so forth. So j is less than I plus 1, and then we can increase j. And so depending on what j is, if we're thinking about 5 the first time, I is going to be equal to 0. So j is going to be equal to 1. The second time, I is going to be equal, I is going to be equal to 0. J is going to be equal to 1. And then 1, 2, 2, 3. 3, 4, 4, 5. And then I is going to hit 5. It's going to break out of our for loop condition. So we'll go out. And then in each of these, we just want to print a star, because if we do out.println, what you'll see, delete this, is what this will do is it will just print out a bunch of stars and they won't be on each individual row. So what we can do is we can print out out.print. However, this is also going to give us an error because it's just going to print everything out on a singular line like that, which is not what we want. So after each row, so after we've printed out, say, 1 star, 2 star, 3 star, 4 star, 5 star, we just need to add in a print line. And this is exactly the same, just out.println, like a blank call here. This is exactly the same or equivalent to just out.print with a new line character. So you can do one, you can do the other. You cannot do both. If you do both, what will happen is it'll print out the cube like this, which is no bueno. So just only have one of those. And that is the solution, or a solution. Sound good? Question. The Boolean thing?
The
Oh, yeah. Okay. Good question. It does not. Okay. So I suppose, yeah, integers and Booleans are different values. That works in Python. So unfortunately, it does not work in Java, but sometimes they'll automatically let you use one as true, but it does not look like that in Java.
MATLAB we went over that when the midterm.
MATLAB does it?
I don't know if it does that. I just know
No.
like during the
It does.
MATLAB does it?
It doesn't have to be one, it can just be any number besides 0. It's automatic.
I think Python does that too. Java's like the only one who doesn't do it. That's funny.
But what about the C program? What about the C languages? Do they do it too, or like-
I cannot tell you. I haven't programmed in C willingly. That's the end of the sentence. I've never programmed.
And so,
Would have to take C, right?
yeah.
That explains.
You guys all have to take C. It's called Systems 1 and 2. It's dog
Like
shit.
in 1281, we have to take, we're taking C after MATLAB.
Actually?
Yeah.
Ooh,
Like,
yikes. They
well,
changed the
like,
program.
It's much better, like, we did MATLAB first, so then we do C, which is honestly much better because I can't handle MATLAB subscripting my one. It's like,
It's disgusting.
yeah, that's what it is. I'm like, oh my god.
It's the first question you should ask anybody when you meet them is, do you subscript by 0 or 1?
Actually, can you go back to the code? I want to write it down.
Sure. Just take a photo of it. It'll last long. Take a picture. It'll last long.
I get it.
Okay. Any other questions about this? Going once. Going twice. Question.
I don't mean to be picky, but I did the string method. Everything was right, of course. And I remember I did like an extra check just to make sure, where I just had like one extra if statement, and then you took off a point for not being did. It's not like it's like it makes it like inefficient.
Yeah, I think. Let's read the instructions here. I think it says that any
It's like or it might have been last even actually. Like I think I remember like
oh, it was last
I had
even.
it right. I didn't need the extra if statement.
Yeah.
Checking it.
Oh.
Yeah, it must have been because of this. Avoid unnecessary complexities and inefficiencies. Yeah. Midterm 1 was goofy. That's what they're saying. Okay. Any other questions on midterm 1 is goofier. I don't know. I haven't seen midterm 2 yet. It could be easier. It could be harder. It could be the same exact as midterm 1. Though probably not. It could be written in German. Probably not. Okay. Any other questions on
Wait, if it was written in German, could you pass it? Like that's
no. I barely know how to speak English. Okay. Last even. I'm assuming we want to go over this. Or not. Or we can skip this. Yeah, that's what
go.
that is what I thought. Okay, let me copy. Yeah, so for what? Yeah, tell me about it. It is. Okay, wait, I shouldn't have taken off more than 1 point. So if it was just that, then see me after class and I'll. Okay, so we have this method here, which is supposed to report the index of the last even element in the array, or -1 if no such entry exists. So when it comes to methods like this, it's good to always start with your return value. So in this case, return value is going to be -1 if we go through the list and we don't see anything that is even. Now, what most people got points off on and are probably angry about is the inefficiencies. So technically, the most efficient way to do this, I'm going to add the return statement down here. Technically, the most efficient way to do this is to also have a Boolean called found last even. Set that equal to false. And then update that once you found the first, or I guess the last even, because you'll see. Actually, it's easier to explain once we do the rest of the method. So we can start at the back. We can use either a for loop or a while loop. I'm going to use a while loop. So int indexer equals nums.length. And does that have to be regenerated? No. Nums.length. Like that. And I believe it has to be subtracted by 1 because that's how indexing works. So while indexer is greater than or equal to 0. Let's just out.println nums indexer. So this will print out each element in this will print out each element in the array. I think. Oh shoot, I have to make an array, don't I? So if we have the sample array, let me just make it here. Int test array equals 3, 7, 4, 6, 7, 2, 1. Does that work? Yes. And then we're calling last even on the test array. So this should print out every single thing in the thing. Oh, infinite loop. Take points off. And then at the bottom here, index minus minus. So we're starting at the back, and then we're going to the front, and we're printing out just every number in the index. So you'll see we have 1, 2, 7, 6, 4, 7, 3, and that is going from the back to the front. Now, what we can do is we can check if the number at each index is even. Who remembers how to do that? Yeah. So if the number at the indexer modulo 2 equals 0, this is an even number. So we need to do two things. We set the last even equal to whatever the indexer is. Some people got points off because if you read the contract definition, you want the index of the last element. So we wouldn't set last even equal to the value at the index. We would set it, we would set it equal to just whatever the index is. And we can set our found last even equal to true. Now we can go back up here and we can say, why are you infinite loop? Oh, and then regardless, we have to subtract indexer. So now the efficient part where while we have not found last even and indexer is greater than or equal to 0. So the purpose of the Boolean here is that once we found the last even index, because we only care about the last one, we don't even need to check the rest of the list. So in this case, once we get to the second to last index here, we found 2, which is an even index. It will return whatever the index is. We don't even need to check for any others because they will be previous, I guess, even numbers in the list. So we don't care about them. Okay. Any questions on this? And then this would be, yes. Yeah. Right. So when we talk about efficiency, this is a spoiler warning for you take a class called Foundations 1 and 2, where you learn about asymptotic complexity. So it sounds scary, and it is, but lines of code is not a very good way to measure how efficient a program is. And neither is how long it takes to run. So let's say I ran it on my machine and it took like 3 seconds, and you ran it on your machine and it took like 10 seconds. That doesn't automatically mean that mine is more efficient. I could just be running it on like Google's supercomputer, and you could be running it on like a MacBook 1998. No, not like that. I mean, just like that was not a dig. That was not a dig. So instead, we use something called asymptotic complexity. So it essentially uses n, which is the length of a list or a length of something that you're using. And however many times it loops through, it uses instructions computed, essentially. So if you have a nested for loop, so you loop through a list and then you loop through the list again, you're looping through it. If the list is n elements long, you're looping through it n times, and then each time you're looping through the list again n times. So it'd be like all n squared. If we're talking about binary search, like the interval halving, if the list is, say, or the list of values that we're trying, oh, that was a terrible idea. If the list of values we're trying to guess is 1 to 100, in this case, n is the number of lists, but since we're cutting in half each time, that would be log n. And actually, I'm going to pull this up because it's a fun graph, but asymptotic complexity. And depending on whether it's log n, O of n, it has this graph here, which you can see. The ones down here are like O of log n or O of n. The fastest is O of 1 time, so constant time. So we say instructions like setting an integer equal to something is constant time. Setting a Boolean equal to something is constant time. Looping through an entire array of size n is n time. But yeah, so lines of code, that was a long-winded answer, but essentially use this thing called asymptotic complexity, which you will learn about. And this is technically faster because once you found the last even index, it will no longer check any of the other indexes in the array because we'll get to this line here. Found last even will be equal to true, and it will short circuit evaluate. So here, short circuit evaluate, and it'll just return the last even. Okay, so if I print out the print line, the last even, it should print like 6 or 7, I think. And 5. While not found last even. So while we have not found the last even index, and the indexer is greater than or equal to 0. So if we had an array that didn't have any even indexes, so let's say this was like 1, and this was 1, and this was also 1, it would go through the entire list, would not find an even index, and would return -1. The reason that we harp on inefficiencies is because imagine if the list was 10 billion gajillion elements long, it would take quite a while. Whereas we have this Boolean method, it automatically returns the last even. I think this is the most efficient way. Okay. Any questions on that? It's just I just made a test array and then I called the method.
That's not.
Yeah, so this is just the method. This is all that matters. Oh shoot. Okay. Speedrun time. We look at the tree. Oh shit. Where's the okay. Draw the XML tree. The height was 4, the size was 9. The last thing that a lot of people messed up on is tree.child2.attribute value count. I'm actually going to pull up a snippet of what the actual tree looks like. Just give me a second. Okay, so if we have a tree and we're saying, where is it? Tree.child2.attribute value count. So we're saying the tree rooted here, child2, so 0, 1, 2. Now we're in the question tree. Dot attribute value, so attribute value count, and the value of that is 5. Oh, hello. The type of every attribute and attribute value in Java is of type string. So just because count seems to be an integer, it's a string. Any questions on that? Okay, that took a lot longer than expected, but I have time to. Okay, I'll make a recording of the 2 methods from the lab, but just as a reminder, if I can find my talk here, the 3 tips for writing recursive methods are. Who can tell me what they are? Did anybody write them down? Does anybody know?
Have a base case.
Have a base case. Your base case is when you stop recursively calling. What's the second one?
Free lunch.
I'll kill you where you stand. No, there is no free lunch. One of you writes free lunch on your exam. I'm going to tear it in shreds and I'm going to mail it back to you in an envelope. Okay, what's the second one?
Make the problem smaller.
Make the problem smaller. And then what's the third thing you need in a recursive method? This is arguably the simplest one. A recursive call. What are you mouthing over there? Recursive call. Free lunch is essentially the word Voldemort in this class. You do not say it. Okay. Those are the three things you should always do. Whenever you get a problem, think about what is the absolute smallest thing about this problem that we already know. So, big example of like a recursive method would be printing out what's it called? The factorial. So, what's the smallest thing that we absolutely know about a factorial? So we don't know what 17 factorial is just by looking at it. We don't know what 8 factorial is just by looking at it. What do we absolutely know about a factorial just by looking at it? 1 factorial. We know that 1 factorial is always going to be equal to 1. So that's the smallest case that you're ever going to get. That should be what your base case is. So you should stop recursively calling once the integer equals 1 or once the natural number equals 1. If you think about another method, let's say like the increment method. What's the case that we absolutely know how to do is we know how to increment on a value that is between like 0 and 8. You just add 1 to it. We don't know about 9 because 9 gets into 10 and then you have to do carry and all the other BS. So we don't know how to do that. So your base case should be when the last digit is an integer between 0 and 8. Same thing with decrement, except you would go from 1 to 9 because you don't know really how to decrement a single integer from 0 because it gets into -1 and then you have to do the carry and all that other stuff. So that would be your base case. So that's step 1. Usually when I'm writing a recursive method is what's the absolute smallest thing? What's the absolute smallest problem that this code could be run on and how would I go about solving that? And then the recursive step just builds on top of that. I'm going to record a video after I take this midterm about solving the recursive problems from the lab. Any other questions? Yes. This isn't like a thing. Like this is like my thing. These are Stephen's 3 steps to recursion is what you can call them. And then step 4 is there is no free lunch.
I'll write that down.
Okay. Any other questions about recursion, life in general, or recursive methods? Okay. Going once, going twice. Have a good fall break. Stay out of the news unless it's for something good. Don't add to the population. Don't subtract from the population.
Wait.
Oh, I'm going to fail it. It's going to be bad. Hey.
Yeah, good luck.
Huh?
Midterm is so real.
Yeah. God, tell me that.
Okay, can I get the attendance?
Yeah.
Also, if I finished the lab tomorrow during last day, do I have to?
No.
Yes,
You know what? So I'm
I
like,
asked
so
you to
I
check
finished
my
the
phone just to make sure I did it right.
Yeah, what is tomorrow? I'm
That'd be
so
like-
honest, I don't look at the lab.
I'll
It's
put
usually
the
the
problem.
It's like
So I went back
make
in,
a raise.
I wrote it, and then I.
Can you multiply now?
I wrote it out. I didn't do a flow chart. That's gonna take too
Basically
long.
the
So I
whole.
Oh, and then if you have an array full of natural numbers, you can multiply on one of them and multiply on all of them.
It was like 10, and I was like,
That
oh,
one.
wait,
It's like,
let's do it, I don't mind.
I didn't just pull up the thing. It's right here.
Sorry.
I know, I was freaking out. Good luck in your midterm, Stephen.
Oh, I'm gonna fail. It's okay.
What class is it?
Advanced operating system. Bad.
So we don't have a lab tomorrow.
We do have a lab tomorrow.
Then why did you tell us to have a good break?
Well, because preemptively, it's a recursive method. I wish you a good break, and the base case is when you don't have a break tomorrow, or when you do have a break tomorrow. Stop. Stop. Carefully choose. Okay, wait. Count. Okay, so you initialize an array with a natural number.
Yeah.
Okay. Array, count. Yes. Partial. I'm fairly certain this is correct.
Okay, great.
Hello,
I literally just wanna know where you got the Karkin sticker on your one of them.
dude, it appeared in my house.
Really?
Yeah, I found it on a table. I live with like a bunch of people, so shit like just like appearing is like not like that.
Yeah.
But I have like a bunch of friends that work for the thing. I can try to get one. I'll message him. I'll try to get you
Alright,
one.
sweet. That's
But yeah, I
great.
found it in my house and then I was like, this is mine now.
Yeah, that's
Um,
good.
yeah.
Good luck later.
What's up?
Can I pick up my?
Yes. You remember your Oh shoot, I did not bring them. Are you gonna be at lab tomorrow?
Yeah.
Okay, I'll bring it tomorrow.
I was asking, I'll go to electric on Thursday, because I'm asleep.
Yes, if I remembered to did I remember to record it? It's a great question, actually.
FOMO from all these free lunch jokes. I don't know what anyone's talking about.
Oh yeah, there were one.
I'll
Okay,
go
wait.
tell you later.